Welcome to the last lesson of 10.5. Today we are going to talk about finding the measure of angles whose vertex is located outside of the circle, right? And when we see these angles outside, notice here we have a 2 secant situation with angle A being on the outside, and we have another with a secant and a tangent. Again, that vertex A is on the outside, or with tangents, again, that vertex of angle A is on the outside of the circle. So how do we find the angle measure for that? Well, our angle outside is going to equal 1/2 of the far arc it opens up onto minus the near arc it is opening up onto. So in our examples up above, our far arcs would be CD and BP and GCH, and then the near arcs would be the one closer to our angle outside. So EF, BC, or GH. And again, we want 1/2 of far minus near. Now, the alternate to that is sometimes, as we've seen before when we're solving, sometimes if we double that angle outside, it's helpful because then we have just far arc minus near arc. And this is especially helpful when we're looking for one of those arc measures and we're given the angle. So if we see in these examples down below, we are looking for that angle outside. And again, we are given in this first one the far arc, and then we are given the near arc. Now your far arc, I always write it in uppercase letters because it's the bigger number is another way to look at that. So if we're looking for angle X, we know it is 1/2 of our far minus our near. So 90 minus 30 is 60. Half of 60 would give us a 30-degree angle. In letter B, our far arc from our angle is 170 that it's opening up onto. Near arc is 40. So on this one, we would have 1/2 of far minus near. So 1/2 of 130 is 65. And then our last example, this time our far away arc is the 330. The closer arc to our angle is 30. So X is going to equal 1/2 of that far minus near. So 1/2 of 300 is 150. So there are then 2 examples for you to try. First, you are finding the measure of angle D. And then in the second example, the measure of angle B. Now down below in example 2, we again see some angle measurements or looking for that angle outside. This time, notice though, when we look at our far arc, that is given. However, this near arc is not. So before we find the measure of our angle, we are going to start by taking the measure or finding that measure of that near arc by subtracting from 360 the 2 arcs that we have, right? Because we have that remaining measure is going to end up being 60 degrees from subtracting from that total degrees in our circle, which is 360. And then to find that angle on the outside, we can take 1/2 of that far away arc minus the near arc that it's opening up onto. So 1/2 of 140 is 70 degrees. On the second one, again, this time we aren't given the far arc. So similar to the last one, we need to find that by subtracting from 360 the 2 that we are given. And we find out that this far arc ends up being 60 degrees. Near arc this time is going to be the 34. So again, far is 60, near is 34. X is going to equal 1/2 of far minus near. So 1/2 of 26 is 13 degrees on that one. Our last one, we are given the near arc this time is 75. However, to find that far arc, we need to take 360 minus the 75 so that we get our far arc to be a total of 285. And then again, to find that angle on the outside, 1/2 of far minus near. So half of 210 this time is 105. On the back, there are two examples for you to try. For the first one, you are going to find the measure of angle D. Reminder, you need GH first. And then on this one, you are finding the measure of angle T. Again, you will need SU first. All right, in our third set of examples, we are looking this time for one of our arcs. So notice we are given the angle on the outside is 60. And this time we are looking for the far away arc on this one, and we're given the near arc. So we know that that 60 equals 1/2 of the far arc, which we don't know, minus that closer arc. Well, again, sometimes it is useful to undo this 1/2. We can multiply the 60 by 2. That's where this second formula on the front page comes in. And we can double that angle, so we get 120. And we know then that just equals that far arc minus our near arc. So we can add the 40 to both sides, and we end up finding out that our far arc is equal to 160. And again, you can always double check that, because if we plug 160 in, we could double check, okay, does 1/2 of 160 minus 40, does that equal 60? And in fact, it does, so we know we did it correctly. Over here, we are again looking for that far arc on the opposite side given this near arc. So again, we know that our angle outside equals 1/2 of far minus near. So same kind of idea, we can undo this 1/2 by doubling the 75. So we get 150 equals x minus 103. So we end up with 253 as our value of x when we add the 103 over. And then this last one, we are actually looking for the near arc this time. We are given that far arc. So angle is 35. That equals 1/2 of the far minus the near. So we're going to double the 35. And this time that equals 145 minus x. Now be careful if we move this all over so that the x is by itself. 70 minus 145 is negative 75. But that equals, be careful over here, negative x. Well, the negatives will divide away, and x is just equal to positive 75. Two examples for you to try. You are solving for arc VS in the first one, and this major arc in the second one. All right, last page in number 4, we are given the angle outside is 6x plus 6, and we know that this is going to equal 1/2 of our far arc minus our near arc. So in this case, we would have 21x plus 17, and then minus the 86. Well, again, I personally think it is easier to double that angle on the outside rather than distribute the 1/2. So we can just distribute 2. This becomes 12x plus 12. And then on the right-hand side, we have 21x 17, but minus 86 is negative 69. Subtract over the 12x from the 21, we end up with 9x's. Add the 69 to both sides. 12 plus 69 is 81. And when we divide both sides by 9, x ends up equaling 9. Okay, now the last example also wants you to solve for x. Again, you are given that angle on the outside. You have far arc, you have near arc. Set up and solve for x. Thanks everyone for watching. We will work more with these in class.